Hello, everyone, and welcome to section 3.2. After we introduced the 5 different operations on statements, namely the negation, the conjunction, the disjunction, the if, then, or sometimes called the conditional and the biconditional operators, it is now time to see or to investigate how actually we are going to work with those operators. And specifically, we'll be talking today about just the negation, the conjunction, disjunction, and in the next video, we'll be talking about the if and the if and only if statements. And today's topic is on what's called the truth tables of these operators. So after you finish this, you should be able to construct truth tables of statements that are involving negations, conjunction, disjunction, and you should be able to here in this slide, they call it an alternate method of constructing truth tables. Actually, there's only one method. The idea is the same, but there's variations of how to construct a truth table. And then at the end, if I give you a compound statement, when I say a compound statement is a statement that is combining more than one simple statement. If I give you the truth value of these simple statements, can you give me the truth value of the whole compound statement? You will see what I'm talking about later. So a truth table is used to determine when a compound statement or any statement is true or false. Suppose we have a statement B, and this is the basic truth table of the negation operator. So suppose you have a statement B. This statement B can be either true or false. You have only 2 cases, either case 1 or case 2. If B is true, then the negation of B is false. If B is false, then the negation of B is true. As simple as that. So knowing the truth value of a statement, then you can automatically get the truth value of its negation. Okay, how about the conjunction? Well, if you have 2 statements P and Q, they are either both of them true or both of them false. The first one is true, the second one is false. The first one is false, or the second one is true. So you take any 2 statements, you're always going to have one of these 4 cases. Usually we don't put case 1, case 2, case 3. It's just either both of them true, the first one is true, the other one is false, the first one is false, the other one is true, or both of them false. Well, if you have 2 statements true, true and true is true. So if you use the conjunction between them, true and true is true. True and false is false. False and true is false. And if they are both false, false and false is false, right? So as you can see, the only case where the conjunction is true when both the P and Q are true, otherwise it is false. So again, this is the truth value or the truth table of the negation, and this is the truth table of the conjunction. So now let's do the truth table of the disjunction. Well, the disjunction, known also by the or, as you can see, it's all true except when both of them are false. So true or true is true, true or false is true, false or true is true, false or false is false. So the only case where both of them, or when the disjunction is false, when both of them are false, the P and Q. So that's all you need, really. If you know the truth value of P, the truth value of Q, you can do the truth value of the negation of the P, you can do the truth value of P or Q, and you can do the truth value of P and Q. So, but of course, we're not always dealing with the negation of P and Q or P or Q. We may have a more complicated statement that we need to construct a truth table for. And this is the next example. Suppose they ask us to construct the truth value of the negation of Q or P. Well, there are different ways to do this, right? But since I have P and Q here, so look, I'm going to show you something I would say easy to deal with. Maybe the next slide will show us what's going on. So here it is. I have P and Q. First of all, you set up 2 columns, P and Q. Of course, you can start with Q, then P, but there's no reason to do that really. So, and you put all your 4 cases, because if you have 2 statements, you have 4 cases. Either both of them are true, the first one is true, the other one is false. The first one is false, the other one is true, or both of them false. And you write your statement, the whole statement they ask you to do, write it next to it. As you can see, we divided this into boxes So here we have the conjunction, the disjunction between the negation of Q and P. And then after that, we're going to fill, right? We're going to fill the cells of each of the cases. It is just like the order of operation. So first of all, you need to know the true value of the negation of Q and the true value of P first, and then you do the OR and wait till the end to do the negation. And that's what's going to happen here. So first of all, I'm going to do the true value of the negation of Q. So here Q, look, Q, when Q is false, the negation of Q is true. When Q is true, the negation of Q is false. I'm building just step by step, just like in blocks. If Q is false, the negation of Q is true. If Q is true, the negation of Q is false. And then step number 2, I'm going to just, since I have just P, well, I'm going to just reproduce. I'm going to just copy paste those values here. If I had the negation of P, then I would have inversed or took the opposite of those values. So just when P is false, then P is false, and FFTT, or you can do it from the top down, it doesn't matter. Now I'm going to do the OR, I'm going to do the disjunction, which is step 3. True or false is true, false or false is false, true or true is true, false or true is true. So now this one here is the last step that I'm done, that I did, constructing this part here. Right? So this is this column here. Now I need to do the negation of that and put that in this column here. So I'm gonna just take the negation. So which is step 4, which is the last one. False. Why I put false here? Because the negation of true is false. The negation of false is true. The negation of true is false, and the negation of true is false. And this is the final answer. So this, the whole thing, right? So pay attention to this, please. The whole thing is this column here. What does this mean? If P is true and Q is true, the whole thing is false. If P is true and Q is false, the whole thing is false. If the first one, P is true and Q is true, the first one is false, the second one, which is Q, is true, then the whole thing is true. If both of them are false, the whole thing is false. And this is the answer. And let me introduce you to a new definition. It could happen that you get true everywhere here. If this one is always true, we call it a tautology. And there's a separate discussion about this later on. When it could happen that the statement they ask you to work with is true regardless of the true value of P and Q. And in this case, it's called a tautology. What is a tautology? It's a statement that is always true. And this is how it's spelled, tautology. Okay, so here is another example. So here, look at this example here, example 2. So we would like to construct the truth table of this, the whole thing. First of all, I need to set up the P by itself, the Q by itself, and then work on the negation of P, work on the negation of Q, and then work on the whole thing. So this conjunction, the end, will be the last thing to do. So pretty much the same thing. So here's my P set up, here's my Q set up. Here's the negation of P by itself. Here's another way to do it. Another way to do it is just do it in steps. So this is the negation of P. Well, how did I construct the negation of P? When P is true, the negation of P is false. When P is true, again, the negation of P is false. False becomes true, and false becomes true again. And I'll do the same thing with the negation of Q. And here, I'm going to do the whole thing, right? So I'm going to do the end of this. False and false is false. False and true is false. True and false is false. And true is true. So you really need to know the basic truth table of the negation and the OR and the end. So for you to be able to do this successfully. So, and this is, it is recommended that you box the last step, the last column. So the whole thing, the negation of P and the negation of Q, is false, 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 true when you have these cases listed in this order. Okay, well, here's an example. But this time they don't. If you look at the previous example we had, what they gave us, and they gave us the statement already symbolically represented. Now in this example, they gave us the plain English, and they ask us to work on the truth table. It says determine the truth value for each simple statement. Then using these truth value, determine the truth value of the compound statement. So here is the compound statement. The whole thing is the compound statement. Oops, sorry, I didn't circle that correctly. The whole thing says Angelina Jolie is an actress, or Zac Efron is a janitor, but Johnny Depp is not a plumber, right? So here, this is a compound statement. So it is compound by how many statements? 3. Angelina Jolie is an actress. Zac Efron is a janitor, but Johnny Depp is not a plumber. So before we do anything, let us symbolically represent this. So I'm going to say you have 3 statements. P, Angelina Jolie is an actress, which is true. Zac Efron is a janitor, and Johnny Depp is a plumber. So let P, Q, and R. So, and then this statement here, the one I circled, is symbolically represented by, they says what? Angelina Jolie is an actress, or Zac Efron is a janitor, and there is a comma. Have you noticed the comma, right? This comma here, what does this mean? The comma is like, put everything before the comma in parentheses because we have 2 statements, and continue and do the third one. Okay, so here it is. Angelina Jolie is an actress, or Zac Efron, a janitor, and Johnny Depp is a plumber, or is not a plumber because we have a negation here. So if R says Johnny Depp is a plumber, then the negation of R is Johnny Depp is not a plumber. So the statement, we have P is true, Q is false, and R is false. Well, why R is false? Because we know why P is true. Why P is true? Because we know that Angelina Jolie is an actress. Q is false. We know that Zac Efron is not a janitor. How about R? Well, R is also false. Yeah, because Johnny Depp is not a plumber. So that's false. P is true. This is false, and this is false. So given that, so how are we going to construct the truth value of the whole thing? Well, so here, look, you can do this really faster. So I know P is true. I know that Q is false, and R by itself is false. So if R is false, then the negation of R is going to be true. So what is true or false? True or false is true. True and true is true. The whole thing is true. So that's, you can do this faster this way. Or let's follow how these things will be done through these slides. So this is what we would like to construct. So P is true, Q is false, and the negation of R is true. Why? Because R itself is false, and if you put the negation of false is true. Now, true or false is true, true and true is true. So that's the final answer is true. Yeah. So the original compound statement is true. So if you know the truth value of those simple statements, and if those simple statements are put together in a compound statement, well, it's easier to tell the truth value, the final truth value of the whole compound statement. So what we learned today, really, we need to focus on 3 things, basically. Let me just go. These are the cases. You need to know how the negation of the truth, the truth table of the negation, which is this one here. You need to know the truth table of the conjunction, and you need to know the truth table of the disjunction. Once you know these 3 basic truth tables, then using those 3 truth tables, you can construct the truth table of any compound statement that is using either the negation, the or the and. So next, in the next lecture, we're going to be talking about the truth table of the conditional and the truth table of the biconditional. And once we know those, we will be able to construct truth tables of any compound statement that has anything really in it. It may be a little bit time consuming, but if you know the basics of it, if you know how those basic truth tables work, then you know how to construct the truth table of any compound statement, just like I said. Okay, so go now and start your homework on this section. And after you're done, keep working on and watch the next section and go from there.